We're Cougar Robotics, 4251 Columbus, Ohio. I'm Evan.
I'm Joey.
Phil. Sean.
So what is autonomous? It's usually about 30 or 40 seconds at the start of the game, and it's a pre-programmed round, so the people don't actually control the robot. You tell the robot beforehand what to do. And it's actually underrated by a lot of teams.
And one of the keys that we actually don't have up here, but you're playing, because it's at the beginning of the round, so you're playing on a clean field. You know where all of, or at least in past years, you know exactly where all of the field elements are and what the field looks like, so you can program for that.
Things to think about, your autonomous can contain both offense and defense. You can look at scoring points, and you can also look at keeping other people from scoring points. You can also look at the end of autonomous, being ready to go right into teleop. Being set, like this year, we would, in certain autonomous programs, we would line ourselves up so that right when teleop starts, we can go and pick up a crate instantly, because we've already moved ourselves to be right there. Also having many pre-programmed options for different strategies and situations. I think we had 28 different autonomous programs this year for the 4 different starting places, and also the being able to manipulate all of the different field elements. Also, you want to try to complement your alliance partner. You don't want to be running into them or trying to do the same thing as them.
But going into a tournament, you have to think about, you don't know who your alliance partner is going to be. So as much as figuring out what your robot's going to do, when you're preparing your autonomous routines, you're going to have to do some thinking ahead, trying to predict what other robots, how they're going to be moving on the field, and how you could benefit your alliance partner during that time.
So mission design, number one key is reliability. You want your robot to be able to do the task you want it to do every single time you run it. And if it isn't, you want to go in and fix it. And we can go over in the end ways we're able to make our programs more reliable. Also time, you want to make sure, you want to run it beforehand to make sure it does actually fit within the autonomous period. Dealing with traffic, you're not the only robot on the field.
In practice, you might be, if you're practicing on your own field at home, but if you get to a tournament, then there are 4 teams on a field rather than just 1. So now, some programming principles. These are actually really important. So some of our best practices are reusable routines and modularization, and we'll actually cover that more a little bit later on. And then clean code. I cannot stress this enough. You want comments on all of your stuff. You want everything to have its own specific location. So what I mean by that is, especially in Robot C, you have a section for where you define all of your variables, a section for where all of your reusable routines are, and then a section for all of your tasks, and a section for all of your functions or anything else you want to put in your program. And then spacing and indentation. So when you do this, and especially in a text-based language like Robot C is, if it's inside of, if you have code inside of another structure, you indent it in. And if you don't have that set up right, then looking back at your code later, you can't tell without really in-depth reading of it, and even then sometimes it becomes difficult to tell what's where. And the clean code is really for you later. It might take 10% longer to do this as you're going through and writing your program for the first time, but it'll save you so much time later if you want to go back and change or edit your program. And if you make it clean, if you make your program neat and orderly and easy to follow, then you can just look at it and say, oh, I know if I want to go do this, it's going to be right here in my code. But if it's not, then you have to search through however long your program is, trying to find this specific little thing, and that can waste a lot of time. Also, a very helpful tip is your debugging info displayed to the screen. And what we basically do is the NXT, you can put whatever you want on the screen during your program. So it's often valuable to display, for testing, your values of sensors or anything else, a mission selection, whatever you find it would be helpful to know as you're testing or writing your program. A big one we had on there was our gyroscope. That's one of the sensors we use the most in autonomous. So we would always have that displayed on the screen. So if something was going wrong, we could just go look at our screen and see, okay, is it this sensor? Is it this sensor? And that could often give us a clue of why our robot wasn't working the way we thought it should be. So this is the basic flow of how a autonomous routine or autonomous full program should work. So what we've got here, and I realize it's kind of small and hard to read, but we've got a mission selection. What that is we have one program for all of our various autonomous routines. We had 28 at the end of last season, 28 different routes our robot could take based on starting position and what we actually wanted to accomplish. But they were all in one program. So we just had a mission selection, and we did that through a number system. Each program or each routine had a number, and then we could use the arrow keys on the NXT to choose that number. And then there it would save that number, our mission number, and go through our initialization routine. So if you have any motors or servos that need to get set in certain spots, then you can start reading your sensors. So our gyroscope took a while to get set up before the match. And so we would have it start reading, and we could again display it to the screen and make sure everything was working and the robot was getting itself set up before our round even started. And then the wait for the go code. Now that's really important in your autonomous routine. What that is in Robot C, it's a command wait for start. And what that does is once your program hits that spot, it'll wait, just sitting right there until the field control system says, okay, autonomous starts, go. If you don't have that in there, as soon as all of this stuff finishes before it, your autonomous routine will just start. And then you'll have problems because your robot will have taken off early before your round even starts. So once you receive that go command from the field control system, you can read whatever mission you had selected. So we saved it here and we read it here. And then let's say we wanted to run mission 2. We check, is it mission 1? Nope. Is it mission 2? Yes. Okay, so we're going to run based on our input over here. We did that through the number selection. There are other ways of doing it. You can decide on your own how you actually want to do your mission selection. And then it'll run mission 2. And all of these, so based on whatever number we put in, it'll run a different mission. If that said mission 1 or mission 3 or mission 27, whatever mission we actually wanted to run.
So your mission was probably, there were 28.
Yeah.
28 missions.
Yeah, we had 28 missions, but that changes. The year before we didn't have that many.
Yeah.
So it's just whatever scenarios you want to prepare for. And then at the end, once your autonomous routine is finished, a lot of the time you'll have a couple seconds left in your autonomous routine or in the autonomous period after your routine is run, but your robot's just sitting there. What you can use that time for is actually preparing for teleop. So if you need to get your arm in a certain position or some various manipulator set up ready to go for teleop, so that as soon as teleop starts, your robot is ready to go do exactly what you want to do in teleop. So for scoring points or facing towards crates in this game. So you can use that time to have your robot start setting itself up for teleop. And then it can stop. So your robot is done. Your autonomous routine is finished. we have some examples down here of reusable routines, and I'm actually going to talk about that some more on the next slide, but some good ones are reading sensors, moving a distance, turning the robot, moving an arm, and then some specific ones to last year's game, grabbing a crate, grabbing a ball, raising our scissor lift, or turning towards the infrared beacon. So now, modularization. We think this is one of the most important things you can do when programming, and we gave it its own slide just because we thought it was that important. And this goes for both teleop and autonomous. But reusable routines are basically, we use them as functions in Robot C, and Robot C is really good at doing this. So you can define a function, like this is a screenshot of some of our code. All of this is just used to make the robot turn to a heading using the gyroscope. Now, if we wanted to do this every single time, our program would become really, really long, and it would take a really long time to programming it if we had to write that out every time we wanted the robot to turn. So what we did is we took this whole thing, made it a function called turn right wheel. So anytime we wanted to use all of this, we just put in turn right wheel and then a number. And that number would tell us what direction we wanted to turn to. And this is where we get into spend time to save time. Often, if you're using encoders or time or however you're driving, we recommend encoders and using various sensors. But it'll take 3 or 4 lines to do a straight move or a turn or whatever you're trying to accomplish. This takes however many lines this is, more than that, but when we actually want to put it into our mission, we just put in 1 line that says turn right wheel. And so we're spending a little bit more time in the beginning figuring out this whole program that is, yeah, that's kind of complicated, but it works every time. It gets us a precise and accurate turn. So to use it, though, we only have to put in 1 line of code.
And you can use these year after year after year. I'm pretty sure we wrote this our first year of FTC, and we've used it every year since. This is the line of code we used to turn the right wheel at Worlds this year.
And then the other thing with reusable routines is make them usable in different situations. So have parameters, have inputs. So for this, we have turn right wheel. But then we have a number input. So we put turn right wheel, and then we put a number after that. And that number is we put in every time we want to use this function, and that tells us what direction we want to point in. So you can have a go straight line. So we have, say, move a distance. And to do that, you would just put in your number of how far you want to go, whether it's encoder ticks or whatever you're actually using as your units. So we can use this, but you don't have to have a different turn for turning 45 degrees or 90 degrees or 10 degrees. You can have 1 turn and just put in the number of how far you want to turn. And that's actually all we really have specifically